Hi. After optimizing the tower or the floors of the tower and the areas and the cost, we want to continue with creating the bracing of the tower. So we'll take the surfaces of the tower that can be found from the built-up area, and we want to select one of them to create a base for the bracing system. It will be going like intersecting the tower diagonally. So we want to create a get item by index. Let's move this. And we want to create an integer slider from 0 to 7. So we'll be able to select one of these surfaces. Now we want to use the get isoline component. And with this one we'll connect the surface and then create a parameter from 0 to 1 with the number of a. A will also be an integer slider with the values ranging from, let's say, 20 to 100. If we connect it to the parameter, you can see that we have a grid of lines. We can increase and decrease the amount of lines we have by this slider. Let's make this, the minimum is 10 right now, and we can change the surfaces we are selecting so this adapts accordingly. I want to continue with the concept, so I want to extrude the curves and make surfaces. Let's select the curves. Direction will be the normal of the surface. So we'll make it now the easy way, then we'll make it the way that's more correct and the way that will work for us. So we want to get the normal at a parameter. This is the surface and the parameter, let's make it 0.5. This will be the direction. The distance, let's make it 100 for example. You see that we have an extrusion of these planes, but it's going the wrong direction. We want to change this to see what will happen. Sometimes it intersects the tower, sometimes it's not. So to make this safer, we want to do another trick. First off, we want to make this 300. And afterwards we want to create another curve extrude component, but this will have a negative value. Let's say -a. So it will go both sides. Now also another thing I want to do is to make sure that this covers the whole surface of the tower. So I want to just hide those for now. And make the parameter something different. So I want to make the minimum -5. I can do this minus values. it will just extend beyond the surface boundaries. So let's make it a little bit smaller. Let's try these numbers, and if we increase this, it will have the same effect. Now we want these curves also to be extruded, or extended, so we want to move those out of the way. I want to use the extend start and extend end. So the start, this is extending the start, and this one extending the end. I want to make the number, for example, 100. You see that this extends from one side, this from the other. I can extend the lines after putting them to the extend start component. So here it gives me, if I hide those, here it gives me a clean lines, and afterwards I want to extract or to extrude these curves right here. If we hide this one and show this, you can see that it creates a huge matrix of surfaces, or a huge array of surfaces. Now we'll convert it to a matrix by using the isodirection node, changing some values right here. You can see that if we put the direction 0 and 1, it will affect the direction. So we want to put a list of 0 and 1. Now we want this to be cross product. Let's put some smaller numbers right here so it can be noticeable. Let's also use another plane. The whole shape shifted. You see, this one is not guaranteed, so we do this from both sides. Now afterwards I want to zoom out a little bit and create a list with these components, then transpose it. Let's flatten before extruding the curves. It will make it easier. So after flattening, transpose the rest right here and then connect them using polysurface by joint surfaces. This will create a continuous surface. Then I want to intersect this with the geometry of the tower, or the surfaces of the tower. So I want to use the geometry intersect node. And connect it with the tower. Let's hide all of those, and I want to do something for the lacing. Let's make this cross product. It may take some time. You can see that we have some empty lists, but we'll have also a lot of lines and some points. This should be flattened. You can see that here we have mostly lines, we have some points. This is just coincidences. Now we have some nice bracing. Maybe we can do something else. If we change this slider, it will dramatically affect the bracing and the orientation. This gives us a nice optioning tool. This is highly conceptual and it will give us a lot of variables, a lot of variety in the options we have. This looks nice. Anyway, I want to group all this. Let's make this one blue and call it bracing. Now to continue with this one, we want to use an adaptive component. This adaptive component will take the start and end point of each line and apply a beam or some kind of geometry that stretches between the 2 points from start and end point. So to create this, first off we want to make sure that we don't have any points. The easiest way can be just taking the start point and end point, and you will see that we have some null values. These null values will be the points. So we can create a list. Then clear the list. You can see this removes the null values. Afterwards we want to transpose. Here you see we have pairs of points. What we need to do now is to use adaptive component by points. This will take these points and we want to use a family type node, and we should select the type from here, but for now it does not exist, so we want to create it. So let me save and go back to Revit. Go to File, New, Family, and use the metric generic model adaptive. So I'll start off by hiding those reference planes and creating a reference line, and make sure that the 3D snapping is active. Draw a line from this point to this point, does not matter, it's random. Hit escape, then select the 2 points and make them adaptive. Here's 1 and 2. Let's hide the points. Then, since the reference line have 4 planes, we want to draw a circle on 1 of the end planes. Let's click on dimension. Let's draw another one on this plane. Also hit the dimension. It seems off center, so we want to delete it now, and let's redo it again. Now let's select this dimension and create a new parameter. Let's call it size. Hit OK. And we want to select the circle, the line, and the other circle. Create the form. And this cylinder will be the beam we'll be using. If we change this size right here, it will change from the other side until it will stay a cylindrical shape. Let's save this and call it adaptive beam. Load into project. You can see that if we click from here to here, it creates one. So let's delete this and go back to Dynamo. Now let's see the adaptive beam. Here it is. I'll change this to manual. Select the family type and points. I recommend when first trying to push geometry to Revit to start by something little bit smaller. Either you change the spacing or the numbering in the beginning of the graph, or using get item at index node. Let's say select from 0 to 10. Remove Dynamo from the way. Click on the 3D view. Let's change the units. And click run. Here you see it created the beams quickly. You can choose whether you want to make the beams right here or not. If we excluded the surface from the built up area right here. So we want to check which surface it is. I think it's the first one. Let's choose a drop item up rest of items. Go right here and to the intersection and connect it right here. Let's run this again and see the result. So here it is, the first 10 beams. Now we want to select and delete them. The first 11 beams. Delete them and connect this. It will take a little bit longer, but we'll have to wait. So here it is, the beams of our tower.